Right, David. At the end of that, the last piece, we were talking a little bit how scary it is. You know, the temperature increases. It really is scary with those consequences. So let's move on from there. How can we work with that constructively and understand it differently?
Scary means so many different things to so many different people, doesn't it? I was tasked with being an alarmist by one person from the European Commission at one point. And I said, no, the work we're doing may be alarming. I will not be an alarmist. An alarmist uses fear to try and mobilise people. It doesn't work.
No.
This is scary enough on its own.
Yeah.
I think, these things do raise a certain amount of anxiety. Of course they do, because it's change in the way we're going about things. It requires significant change in our civilization and our use of energy. The consequences of not acting are really scary, but the scary stuff is about not acting to solve the problem. It's not inherent in the problem itself, it's solvable. And sometimes when anxiety goes up, we spend so much of our energy trying to deal with the anxiety, we don't solve the problem. That's scary. I think we've got a realistic situation in front of us. We've got a series of issues that need attention quite urgently. I think we have the creativity and the capacity as a human species to rise to this and deal with it. But not if we behave as if we have no power of ourselves to help ourselves and sort of regress into impotence. And, or if we feel that it is so anxiety-creating that we become paralysed.
Yes.
So I think we can kick both of those into touch.
Right.
And let's get in touch with some reality here. Hold each other if we are feeling a bit anxious about it, and get on with the job of solving the problem, which deals with the anxiety as well.
Exactly, because what you're saying is fear can be a very useful alarm.
Absolutely.
But it turns into anxiety when we don't really believe, well, when we don't believe we can do anything about it.
That's right.
And that's really what you're saying, I think.
That's right. And I think with my background in psychology and psychoanalysis research and so on, spot on. People become paralysed by anxiety that is triggered by the reality of a situation, not by the reality itself. Right. So let's move on and deal with this in a healthy, reality-related, problem-solving way.
That's what we're on.
Take the word scary out of the agenda, I think.
Yes. So
thank you.
How to use the alarm system constructively.
Absolutely.
Yeah. Okay.
We were talking about consequences. One of the consequences I didn't mention is what we call tipping points in the system. And tipping points have become ubiquitous. They're used in all sorts of situations at the moment. A tipping point is where the behaviour of a system exists in one particular state, and you push it to a boundary, and it then will switch over into another way of behaving. One of the ones that we look at is the behaviour of the Gulf Stream, which brings a lot of heat from the tropical areas to the shores of Western Europe and makes our climate and weather so benign, even though it does oscillate quite a bit. There's an understanding that if the water of the North Atlantic becomes a lot fresher, which it can do with a lot of ice melt and a lot of extra rain, we might get to the point where the Gulf Stream goes through a tipping point and either slows down a lot or switches off completely. Unlikely to happen this century, but it's a possibility in the long term. That would have quite big consequences.
Anyway, it's an example.
So it's an example of a tipping point. There are many others. For instance, the Amazon rainforest depends on receiving a certain amount of rainfall on the edge of the continent. That is then taken up by the vegetation. It evaporates, it goes on, it rains a bit further inland. That evaporates, it goes on. There are about 7 cycles of evaporation and rainfall maintained the tropical rainforest. If that starts to be interrupted at the coast by deforestation or by drought, then you tip the rainforest in the Amazon basin from the tropical rainforest into a savanna state. And since the rainforest absorbs about, something like a third of the carbon dioxide in the carbon cycle every year, it's the lungs of the planet, and that would increase the rate of heating dramatically.
It would amplify it yet again.
It would amplify it yet again.
So
there are about 9 tipping points from areas of monsoon, rainfall patterns, ice cap melting and so on that we have identified. And those are well published and well known. The actual threshold at which they are activated is less certain, but they are there in the system. There is, however, a critical threshold, or a tipping point, if you like, in the Earth's climate system as a whole.
Ah, that's interesting.
Which is much, much more significant and much more important to look at. And that's the boundary between a climate response to our disturbance that reaches a new equilibrium at a higher temperature, an equilibrium-seeking response, or one that goes out of control in self-amplification or runaway behaviour. Historically, that's never happened on the planet before. But what we have done in the last 100, 150 years is initiate a rate of change that is about 300 times faster than anything that the planet has ever seen before. Perhaps in response to a massive asteroidal impact, it has been equalled. And the forcing of the situation away from equilibrium between energy in and energy out, the gap in the energy balance, is 200 or 300 times greater than at any point in our historical paleontological record. And under these conditions, and with a high sensitivity, which we've already noted, the threshold between seeking equilibrium and moving into runaway is very narrow, narrowly balanced. And there are half a dozen other processes which we are triggering already, which are narrowing that gap further and further, and could well, in the next few decades, push us into a period of what we call self-amplification or runaway climate change.
And does that kind of eventually stop? Or
Yes. Yes, no runaway is ever infinite.
just,
Even the feedback in the room with the amplifier gets to a certain level of volume. It's intolerable, but it doesn't go on getting louder and louder and louder and actually blow the building up.
So
there are factors that slow down the feedback processes as they go on. For instance, there's a limit to the amount of ice that can melt.
Right, yes.
So that feedback stops at a certain temperature level.
Yes.
There's a limit to the amount of carbon that's stored in the rainforests and other vegetation areas, which when burned goes into the atmosphere, and then there's no more to burn, so that feedback stops. There's a limit to the amount of methane that is stored in the tundra, which is already starting to be released, and under the ocean in what we call clathrate deposits. Temperature will release that. It is a long-term, slow, powerful feedback. It does amplify the problem. It could push us beyond the boundary into runaway behaviour, but there's a limit to that, and it will eventually, maybe over several thousand years, slow down, and the runaway will run out of steam.
And then you've got another state.
And then we've got another stage of a few million years where the temperature comes back down to something that's tolerable. But we're looking at an increase of 10, 15, 20 degrees in the world as a whole through that process, rather than 2 or 3 or 5, which is what we're looking in the equilibrium.
But there is a risk of runaway.
There is absolutely a clear possibility of that threshold being passed. And those of us who are trying to monitor that boundary are increasingly worried that we are very close to it, if not in fact overstepping it.